He is a visionary hardware engineer with an impressive track record that boasts collaboration with tech giants such as, well, Google, Facebook, and Amazon. Known for supporting the development of cutting-edge products during their early stages, particularly in the realm of high-volume consumer electronics, our keynote speaker has dedicated years to bringing forth the technologies that will power the gadgets of tomorrow. Please join me in welcoming to the stage Nima Banai.
All right. Well, good morning, everybody. Thanks for coming. Wow, this is a big crowd here. Appreciate it, especially first talk in the morning. So, what I want to talk to you about is how you actually, in practice, bring a product to market. This will be sort of less conceptual best practices, more in practice what is actually happening in smaller companies or larger companies. I'll get into technical details. You can ask questions, afterwards. But let's sort of jump into it. Actually, before we get started, just show of hands, how many people here have a technical background? Either you're an engineer yourself or PM working with engineers. Okay, cool. And then how many of you work on something that's not just software? So something deep tech, heavy industry, manufacturing. Okay, cool. So I'll focus on sort of the hardware development side of things. I think that'll be more new, more interesting to you. I think a lot of you are familiar with software. So a couple things I want to cover. One is just an overview of the development process. And we'll get into some of the details. What are the different gates that you need to go through in order to bring a product to market successfully? And then next, I'll get into sort of the prototyping vertical, which is very key and often overlooked, and tell you sort of best practices on how to effectively do prototyping. This could be applied to both software, hardware, any stack of product development, you can apply this. So let's get into the first step, is sort of what does the product development process look like end to end? I guess before we get into that, I wanted to start with this quote. Why are we talking about sort of the boring processes? Why don't we talk about sort of more interesting, brainstorming of ideas? That's, more fun, and that's important, but really this kind of captures, talking about the thing or presenting about the thing isn't really the thing. It takes sort of rigor and process to actually bring a product to market successfully. And so this is why we're going to talk about boring process. So there's really 4 levels to the stack. One is obviously documentation. So, these are acronyms. We'll get into what each of them stand for. I think if you're in software development, you're familiar with a lot of them. But the first step at a high level is really documenting what you want to build. And this documentation is important because when you have engineers or technical talent that are trying to actually build your vision, you need to make sure that they know exactly what to build. You want to have the correct trajectory set. And so that is really the important part. Documentation, if you're at a bigger company, is more rigorous. If you're at a smaller company, if you're at startups, you want to be more agile, you do a subset of these. You don't have to go through all of them. Next, we'll get into prototyping. So this is where I'll dive deeper into, both from a software perspective and hardware perspective, what are each of these gates that you want to execute on to bring the product successfully to market. And then production, this I think most of you will be familiar if you're in software development. On hardware, I'll also dive into what are the different production gates, what does it take to actually produce a consumer grade piece of hardware, and then the last piece is shipment. So once you've built it in scale, how do you ship it, how do you develop it, send it to customers, how do you deliver it successfully? All right, so first part is documentation. These are sort of these are general terms. They're not specific to a company. There's sort of 3 different levels that you need to build to do documentation effectively. If you're a smaller company, like I said before, you don't need to go through all of these. But really, if you're the founder or head of product, you want to capture the idea that you have. And that's sort of the first three set of documents. So the idea statement, you have marketing and business documents. Larger companies go into depth for these. Smaller companies, it's sort of like a paragraph statement of what you're actually trying to build. The next three, the product requirements and the engineering requirements and spec, those are key. Even at smaller startups, I would recommend you actually put effort into capturing those. And really the PRD is capturing every detail of your product, every step. So, even down to what does sort of a third screen on your app, what is the color of that button look like? You want to get and capture as much detail as possible, because your engineering team is going to take that product document and then write an engineering spec and execute on that. And that's what you will generate tickets off of. So if you don't capture this correctly, you come back 2 months later and your team has built something that wasn't intended. And so you want to do that and capture as much detail here as possible. And then your engineering lead or whoever's your tech lead will then take that engineering spec and create tickets for your engineers. So that's sort of high-level documentation. How do you effectively do that? Next, we'll get into prototyping, and I think I'll likely just focus on the hardware side because I think that might be more interesting to this crowd. On the software side, when you're trying to prototype, there's really different, three different levels too. So you do firmware coding, you do sort of the middleware backend, and then you do front end, and then you integrate them. And so these sort of general gates in software development capture those, and then at the end, you have sort of this integrated software image through the stack, and it's ready to be used by your sort of extended software team, and the hardware, which is sort of the first prototype hardware that you've built, that software is ready to be flashed onto that. On the hardware side, there's, at this stage when you're prototyping, you're really not going for form factor or cosmetically perfect hardware. You're really trying to vet out the functionality. So there's sort of three different gates in the hardware development process. One is sort of a non-form factor board. I have examples of what these actually look like coming up, but basically if you imagine you have circuit electronics, this first non-form factor board is sort of a flat, the exposed PCBs. It allows your firmware engineers and your hardware engineers to tap into different electrical signals and really verify the hardware that you're trying to build. This is not form factor. This is not sort of production ready at this point. And then you have some proto builds, which are a little bit more mature hardware. And this is when you start to do sort of the hardware validation testing, this HVT step, which is really the first set of hardware that's coming off of your factory line. So you're getting early hardware. The hardware here is really designed for your developers. It's sort of, you're building dev kits at this point. Next, we get into production. So you have a working prototype, sort of a demonstration of what you're trying to build, and now you're trying to scale it in production. So software, I think deploying production software is, you sort of start the development, you develop the features, you create a beta candidate, and then you deploy that, and then you lock the code. This is sort of very high level how you do, and then you have sort of 2 week or however is your cadence for the code commits. On the hardware side, so we'll talk more about this, this is very key, and each one of these steps really are involving the entire stack. So software engineering, hardware engineering, manufacturing, this is typically where you're, if you're manufacturing overseas, you have teams traveling on site. You have engineering validation builds, you have design validation builds, and then you have process validation builds. On the engineering side, that first gate is, this is the first set of hardware that's coming off of your factory line. And so it's really designed to nail down the functionality of your device, whatever you're trying to build. You're not trying to focus on cosmetics at this point. That's where design validation testing comes in. That's when you're tuning all the parameters for your manufacturing, for your injection molding device, for example, your all the processes that you have at the factory line to make sure you're producing cosmetically sound products. And then process validation and ramp, that's when you're really trying to scale what you've proven out. So you know that it works, you know that it can look good, and then now you need to ramp that up. This cycle is typically about 9 months to a year, so this takes a lot of time, a lot of effort, a lot of travel back and forth with your factory. And in parallel, the software track is sort of doing continuous improvements and continuously shipping code. And when there's hardware available from each of these steps, so let's say you have an EVT sample, the set of code that is available at that time is flashed on that hardware, it's validated by your engineering team, and then the software team goes off and keeps developing new features while the hardware team is focused on sort of the next gate. And then last is obviously shipping, right? So you have the products produced, whether it's software or hardware, some of these apply. You have milestones like okay to ship, okay to announce the product. And then if you have physical goods, you have logistics, distribution. And then when you have the product in the market, you have to have a plan around end-of-lifing features or the product and shipping updates. And if it's a physical good, you also have a thing called RMA, which is you buy the device and you return it. How, as a company, do you handle returns? So this is sort of end-to-end. How do you actually bring a product in practice to market? Thought I'd show you guys an example. This is a product that I worked on, startup. We were trying to build a smart light switch. So this is a dimmer switch, the US type. It's a sort of a rectangle. So the first step was the prototyping, so non-form factor. You can see the board on the left is sort of flat laid out. This is what it looks like. It allows your electrical engineers to sort of dial into the exposed signals electrically and verify functionality. You have, the white plastic is clearly, 3D printed, not form factor. You're just trying to prove out the product at this point. Next is when you get to the mass production side of things, and this is what those samples look like. So these are, they come off the factory line, your engineering team takes a look at it, and then you ramp with, after you've validated the process. And then last is logistics, so you ship the product. So next I want to kind of dive into the prototyping loop and how do you do that effectively. So this is at a high level what you do when you want to prototype. So you have the initial documentation set, you've captured the essence of what you're trying to build, your engineers are clear what to start building. And so you enter the loop of prototyping and you design version 1, so in this case I equals 1. You build version 1 and then you start to test with the first set of customers. In an ideal world, if everything was perfect, obviously you would exit the loop here and you go to production and you ship it, everything is perfect. Never happens. So you come back, you take the feedback that you've received with that first V1 and you roll that back into design iteration 2. And really the key is to do this very quickly and efficiently as possible. So obviously we got to talk about AI, everybody's interested in it these days. How is AI impacting this prototyping step? This prototyping step is really key because you want to do it quickly, but you also want to focus on the right things and prove out the right things. And so the speed at which you can do prototyping effectively is impacted by AI. Not just the speed itself and not just making very high quality prototypes, but combining the both together. So on the software side, there's a lot of no-code prototyping that will come up and it'll produce very high quality software, meaning it'll really capture the essence of what you're trying to do. It's not a looks like, it's not sort of just some screen that you can click the buttons, it actually will function and you're already seeing that. And by the way, the impact that I'm talking about, this is currently what I'm seeing being used in industry. It's not what could happen or what could come up. I think the possibilities of that, there are others here that can better talk about few years down the line what you could do with new AI tools. But what I'm talking about here is actually today you could use tools, and we are using tools to do prototyping effectively. On the hardware side, you really have these fab houses that can print you circuit boards. You have machine shops that can make you mechanical parts. You have sort of lens makers that can etch, custom lensing for you if you're building that type of product. And with AI, you can actually start to describe with natural language what you want the performance to be. So a technical description, not just high level. And the AI will then generate CAD files or schematics and send it to machine shops or fab houses for you, and it'll validate it by itself. And so before, you actually needed prototype engineers. There are teams within companies that are focused on prototype engineering. And now you can actually do this in natural language and describe the technical aspects, and it'll spit out a schematic or a CAD design. I'll leave you with this. I think this sort of captures what I was trying to say about prototyping is, fast gets good before good gets fast. And so if you have two startups and one is sort of waiting and trying to perfect the prototype before they present it to the world, and you have startup B where they're quickly iterating on their product, startup B will get to a high quality product faster, and they'll also have the muscle to quickly iterate beyond that. So you want to have that in-house within your team from the get-go. That's it. Wanted to also give a shout out to folks here at Techsylvania and Cluj for having me again. It's great to be back after 8 years. So yeah, thank you.